as I mentioned in the atoms and isotopes video, not all, but most elements have more than one naturally occurring version. So, and the difference is only the number of neutrons. Neon was the example in the last video. So, these three neons are all neon. They're all stable, so they're all normal. But one of them does occur more often. So on the periodic table, the masses that you see are accounting for which of those isotopes is more likely. If you've ever tried to figure out what your GPA is going to be at the end of the semester by, doing weighted averages, so knowing that AP classes are worth more and honors classes are worth more and regular classes are only worth a 4.0, this is kind of the same thing. The way they even figured this out to begin with is what we call mass spectrometry. So you take a substance and you put it in here, and then it shoots it through the mass spectrometer and it separates it into parts based on their weight. And you end up with a graph like this. So if you took a sample of silicon and you put it through the mass spec, then what you get is a readout of not only what are the different masses, but how many of them weighed that. So obviously silicon has a lot more atoms that weigh 28, but it does have a small occurrence of atoms that weigh 29 and 30 because of one or two extra neutrons. So when we're figuring out what's the mass to put on the periodic table, we have to take into account that way more silicon weighs 28. It would be inappropriate to say that the average mass of silicon is 29 because there's only a very tiny percentage that weigh more than 28. The way to figure this out is really easy. So basically, figuring out the average mass is just the sum of the mass of the individual times its percentage. So if we're figuring out copper, there's two isotopes. Copper 63 is 2/3 more, like it's about actually a little bit more than 2/3, 69.17%. But there is copper 35, that's about 31%. So if we're figuring out the average, you want to take the, as exact as you can, 62.9396 times, and then we're going to turn this into a decimal instead of a percentage, 6917. And you're going to add it to the other one, 64.9278 times 0.3083. So multiplying it by its percentage before you add them together is going to adjust the numbers to account for which one of them is more common. So I'm just going to say this was all in brackets. The answer is 63.55256, etc. This was obviously a lot of sig figs. This was only 4 significant figures. This was a lot. This was 4. So I'm going to go ahead and just say that we have to limit it to 4 because multiplication was involved here. So we're going to get rid of those last couple digits. So the average mass of copper is 63.55. One easy way to know if you're doing this right is to check the periodic table. Once you get an answer, if you look at the periodic table and you have basically the same thing as what it says, then you know that you did it right.